Welcome to voxel. In this video, I will demonstrate calculation of voxel-wise incoherence maps over the long images. As a start, we'll use the image from the cohort of 40 patients that was processed last year. We use the same registration that allows us to delineate the lung on all time points. And this is just a reminder of all the result. So there are 250 time points. This process is entirely automatic, and there is a nice long match on all time points. In addition, this technology was upgraded to include the Jacobian map for every time point. Jacobian map is for every voxel, it contains the deformation coefficient. So if the coefficient equals 1, it means there is no compression or dilation, and more than 1, it's dilation, less than 1, it's contraction. So on initial, it's done in relation to initial time point where this Jacobian is uniformly 1. And as we proceed through time, we'll see the pattern of the contraction and dilation for each voxel of the original long time point. See, this is the Jacobian maps. They don't move, they just correspond to the initial time point. But you could see how when the lung expands, the Jacobian becomes above 1 virtually everywhere over the lung. And also it's fairly periodic. So for example, on 2 maps, we can look on time activity curve. Well, it's not, it's a Jacobian curve. Yeah, as you see, you could see a regularity over the time. And this gives us basis to apply the incoherence measure calculation. So there is this new function on the workflows lung MR, calculating incoherence to map. You select the Jacobian map, and then you press the lung MR, calculate incoherence, all default parameters. So we obtain the incoherence map separately for each lung. And then also the period, incoherence period map is calculated, but it's not shown. So now we perform for the other lung. And so we have 2 lungs, and it's incoherence map of the time varying deformation coefficients of how regularly lung dilates and contracts in each specific voxel. Thank you very much.